Hi, it's Terry Dennery, the MathWorks. So let's continue with this inclined plane problem. And so we'll just kind of pick up from where we left off. And so we answered that first question. Second question, what value of the static friction coefficient keeps the block from moving? Well, that's kind of an easy one, I believe. Okay, and it's really that driving force will be equally balanced, that driving force will be equal to what that static force limit is. And so we'll simply set mu stat times n equal to the driving force, and we'll solve for mu stat. I'll call it mu stat required, I think. So let's just kind of get started on this. So live editor, get into code mode, and so I'll call it mu stat required. Right? And so that'll simply be that driving force, tab fill, and then we simply divide it by n. Isn't it nice how this stuff is already calculated for us? That's what is great about coding. All right, so let's go ahead and hit run. And there, oops, what did I do wrong? Oh, 2 equal signs, okay. There you go. All right, and again, kind of getting back to the whole negative stuff, that's just kind of, static friction coefficients are always going to be positive, and so maybe this is the way I'll fix it. I'll just say, put in the minus sign right there. Actually, you know what? Here's a better way to do it. Right. Absolute value. Okay. That's the real requirement. So now let's hit run, and now it's a positive number. Okay. Let's see. Oh, that should be in front of that. So let me just kind of control exit. I'll paste it right back like that. Okay, so let's see. So we're going to do about 10-minute segments on each of these videos. So it looks like we got plenty of time to do another one. What is the acceleration to block down the plane? Well, sounds easy, simple. It's gx, right? That's the gravitational acceleration, but we do have kinetic friction too, right? And so what we're going to calculate this time, I'm going to call it the real driving force. Right. So again, naming variables can be hard, to come up with things that really capture it properly, but let's go ahead and do it this way. So I'll call it real driving force will be equal to m times gx, but let's also get that kinetic friction in there. I'm going to come back up here and we'll just take a look at this a little bit. And so we know the block's going to be moving in the negative x direction. That's what down is. All right. And so it means that kind of like this. Let's see if I do this right. Control 2. Yes, I created zoom in again for me. And Control and Shift allow me to create an arrow. And that's going to essentially be the direction of our kinetic friction. That its role is to oppose the existing movement. Friction always is opposite of kind of what the driving forces or driving motion will be. Right? And so anyways, we saw that that's pointing uphill, and so this will be a positive. Right? So we'll go plus mu kin for kinetic times n. Right, we're kind of crushing it now. We're just doing these things super fast. And so the real driving force is that. And so the question, though, is what's the acceleration? I'll call this, we call it acceleration. Well, I could just call it acceleration period, but I'm going to throw the x in just to remind us. And we know that the acceleration in our setup y-axis will be 0, but let's go ahead and call it this. It's going to be equal to real driving force divided by m. All right, so minus 3.2, so highly reduced from minus 9.8 if it was just going down vertically. All right, so now the next question. look at that, it's in italics. Well, that's supposed to be an answer, so let's just kind of correct that on the MATLAB side. We'll get rid of the italics, right? And it's basically saying how far will the block travel in 1 second. Well, we just calculated the acceleration, and we know it's a constant acceleration. So from calculus, we kind of got this very useful equation, which is x is equal to x0 plus v0 times t plus a times t squared divided by 2. All right, and so let's kind of use that, and we'll do our calculation now. So we'll get into code. I'll just kind of copy that in, even Control C. All right, and we got some things that we need to introduce before we can run that. Basically our initial conditions, right? And it didn't really say it in the problem statement, and that's probably because I didn't kind of copy it precisely. But the wording they'll quite often say is starting from rest. And so as soon as I ever hear starting from rest, what that tells me is that for sure v0 will be equal to 0. All right, and let's then talk a little bit about x0. And this is kind of the thing that will drive students crazy is, well, you got a choice, and that the real question really is, what's the delta? And so for me, I almost always, if I can, I make the choice that x0 will be equal to 0. All right, and what is that? Yep. x0 is equal to 0. Got it. All right. Okay. And with that, we're almost there. And, I'm not going to call it t. I'm going to call it, this is kind of a dumb name, but I'll call it t1. Right? Just meaning that it's 1 second. All right. And it's because I like kind of have formulation because, when you kind of use these things, it's good to kind of have stuff captured with kind of variables. And so anyways, I think that's it. So wherever I had t, now I put in this t1, and so let's go ahead and hit run. Oh, what's this? Oh, it doesn't know what a is. Okay, well, that's because I don't call it a. It's acceleration x. Right, so let's just copy that and replace a. Oops. Paste that in like that. All right. Okay, so that's how far we will go in 1 second. And so now, our next question, and this is our last question, and it's how long will it take for the block to travel 2 meters? So I think what I'll do is I'll just kind of wrap up this video, and we'll do a third video. And that's a little bit of a tougher question, because what it's really going to get at is, and you can kind of see it here, we're going to basically be solving this problem where we know x, but we don't know t. And so we're going to basically put in a 2. And it turns out that it's traveling in the negative direction. So in reality, it'll actually be -2. Right? And so we'll kind of use that, and we'll use the quadratic equation, and we'll decide, is it the positive root or the negative root? But anyways, let's kind of wrap up this one, and then we'll do a third video to finish up.